All right, so let's look at Java. Just go over a little bit about Java. Just a little history of it, right? If you read about it, you know the history of Java. It's always good to know what each language, how each language got started, and who started it. So, as you know, Java is not as old as C. C is really old. So Java is a derivative of C, the C language. If you don't know C, C is a really old language way back in the 70s and 60s, probably around there. So it was found in 1991 by, it was not by Oracle. Okay, Oracle bought it. It was by Sun Microsystems way back in the 90s, and then Oracle bought it out in 2010. So it's now part of Oracle. It was originally called Oak. It was taken by another company, so they couldn't use it, and so they, I guess one afternoon, they just came and huddled together, and I guess someone was just drinking coffee, and there it is, Java. So the name Java came to be the official name of the language. Okay. Many years later, so we have a so Java was initially designed or developed to program, appliances. Okay, it was not meant to use like we use today for web and many of these things going up, but mainly just for appliances, like your remote controls, your refrigerators, and microwaves, and so forth, right? And it's interesting. It's good because the way it started, and now Java becomes what's called a write once, run anywhere language, as you see down here, Aurora. Okay, so each language tends to have their own slogan, and Java is that Aurora. As you can see in jQuery, which is another unrelated language, but it has its own slogan called write less, do more. Okay, that's for jQuery. So that means that with the write once, run anywhere, and that is the purpose of Java. It can run on any machine, any device, any system in the world. From anything that you see, you touch today, I can guarantee that it's probably Java. Okay, from your watch to your car to anything that is run on a machine. So, and the reason why is because of this thing called Java Virtual Machine, which I don't see it here, but there's a virtual machine. Really, a machine is not a hard thing. It's not a hardware, just a software, piece of software that run on the JRE, and you install that on any device. And that JVM will talk to the underlying machine or device, and then that's why Java is what's called write once, run anywhere, any machine. Okay, so it's portable on almost anything that you can think of, and so in that sense, it's very powerful. Okay, so we have, so in the mid '90s, Java, because of the popularity of web, so they decided to kind of switch gear. And they are moving towards the web, so they started by using what's called the applets, right? So it's a tiny application that you can run on the web server and web pages, and it's kind of like a the counterpart to a competitor for Flash. You remember Flash was back in the days, okay? So you have a little component to run on the web, and applets, which is like Flash. The only thing with applets is that you have to write the code and then render it into the app, and then you can install it on the website. So if you make any changes, you have to go back to the source code and make changes, and then recompile and then upload again, just like Flash. Okay. So yes.
So how do you determine? Is there a when you say render into an applet, is it just basically compile?
Yes, you compile it to a in a special executable file, and then you would run that on the web, and then you also need an engine to run it itself, just like Flash. You need a Flash player. Yeah, so same idea. So you would embed it with the object tag, and then there you can run your applets. Okay, and they became obsolete, just like I think around the time when Flash became obsolete, when HTML5 came out, and then HTML5 just like, hey guys, get out the way. It's much easier now. We can do so much faster. You don't have to recompile all the stuff. We can do animations. We can do all sorts of stuff. So that's when applets and Flash kind of phased out in the mid 2000s, right? So now it's you can still write applets. You may still see the still has some around, especially in the banking industries. Banks still use them. Same thing with Flash, because they just refuse to change, right? You know how banks are. If things work, they don't want to change. So you'll be surprised that they still run applets on those. And then we have many libraries. We call this the APIs, right? API is just another interface or program interface that would talk to the main program, and then with that APIs, you have different ways of doing things. So the Java library has a lot of them. Some of these are like, for example, if you write web pages with JSF, with Java Server Faces, JSP, which is very similar to PHP, and you know, and many others APIs. So these are built by Oracle, some are by third parties. Okay, so that's what they are. And then to be able to build or you write your own software, you need this JDK. We talked about this last time. This toolkit here. Okay. Okay. So these are the editions that come with Java. There are three major editions: the standard, enterprise, and the micro, which is for mainly just for mobile devices. Okay, if you are going to mobile phones, you write application for mobile phones, things like that, you're probably using the micro edition, the Java ME, which is the one. I think it's also the same one used for like mobile app development. Okay, so if you want to build web pages, you will have to use the EE version, because this one here uses a server, and you need a server to run both the servlets, the JSP pages, and JSF. Okay, but for this class, it's an intro course, so we're just going to be using the SE edition, and that's completely fine. Again, if you install the AE, that's even better. Okay, so that takes care of all the EE, the SE plus all these features here as well. So as you can see, my version is a EE version. I think last time we installed the Java EE version with your Eclipse, right? Okay, so these are the three main editions. Latest stable version for the JRE is 8. I think they're moving up to 9. I think it's already out on the market, but it's not widely used yet. A lot of people are still in the 8 version. It's just that they have some major differences in terms of security and you know, integration with the servers and so forth. So, but a lot of the coding, the core stuff are still the same. So that's why Java EE 8 is still widely used today. So down here, I put this diagram here to show you where things are. Let me just kind of resize this just a little bit. It tells you where Java is amongst other languages. So I hopefully give you a feel of what's like. Okay, let's talk about a little bit about these different layers, or different I call these dimensions of a language. Okay, so a computer language comes in many dimensions. As you can see, I didn't list everything here. It's almost kind of hard to do it, but at least some of these are kind of important. So we have the low level, high level. Okay, you always refer to those two. The low level is always the one that's closest to the computer language, or the binary, right? The zeros and ones. And as you can see there on the list, the only ones that I know that still exist today is the assembler or assembly language, which is almost very similar to the zeros and ones. Not exactly zeros and ones, but very close to the layer, so they categorize it as a low-level language. And it's very hard to code. Okay, if you've never seen it, you can Google for it, see the source code, how it's done, but it's really hard because when you do a really simple addition, you just want to add two numbers, it will take you about 5 to 10 lines of code to do that. Okay, you're moving one register to another one, and then you keep moving registers, and then you add, and then you move it back and forth. So just doing that is really complicated. You know how you would do it if you give you two, marbles or 4 marbles. How do you add them together? You move one at a time, and then back and forth. So those process is really slow for coding, but when you run it, it's really fast. It's much faster than any language on the right side because they are high level. Okay, so the high level is just because they're higher above the computer. So high level means that the language or the code that you see are written in just English terms, right? If you see like if A bigger than B, then do something else, do something else. So it's almost like math, the regular English phrases. So all of those are high level. As you can see, most of the languages we use today are high level. And there are some are even higher than the high level. And so we have what's called a different generations of language. So the low level will be like generation 1, high level is generation 2, then the higher above that is generation 3 is coming out eventually. But you see that already, is that you know all those like drag and drop features. You don't have to do any coding, right? Just like a block of code. If you ever participated in the arrow code thing, you see that you go in there, you know, some little kids do coding, just drag and drop little tiles into each other like a jigsaw puzzle, right? And they just run in the background. So that's the third generation, and I think that's where things are kind of moving towards as well. Eventually, you're just going to drag and drop. You don't have to know the code anymore. It's also a scary thing. So we have the low level, high level. So Java is a high level, as you can see. And then we have a what's called a general purpose and a specific purpose. Okay, some languages are only work for a very specific purpose, like HTML, right? You won't see HTML on you know, on other machines or other use other than just for web design, web pages. Same thing with CSS, Mathematica, Lisp, Prolog, and Gogo. Those are for the AI purposes, right? So they're very, very specific. The general ones are like most of these languages you see here. You probably heard of these or seen this before. Okay, Java and C and C++. All these are all multi-purpose because you can use it to build many things, not just one language or one application, but pretty much for all sorts of applications, all types. And then we have the strongly typed and loosely typed. Okay, the strongly typed would be like everything in the blue box here, and then the one in the pink or purple box here would be the loosely typed. What that means is that when you declare a variable, sorry? Oh, sorry. I couldn't see from here, so. Thank you. Hey. No problem. So the strongly typed, as you can see, is every language out here in the blue box, or outside of the purple box, or the pink box, are strongly typed. That means that when you declare a variable name, you have to specify the data type, right? So every variable has to have a data type, either an integer type, a whole number. If you remember your math back in the algebra or math, you have like real numbers and whole numbers, integers, right? So like those. We have the character type, you have strings, and then objects and so forth. Okay, so before you can use any variable, like in math, you say, you know, define x equal to 10, something like that. You have to say x has to hold a certain type of number or a certain type of data, right? That's the strongly typed. So that's why it's called strongly typed. And then the loosely typed are just the opposite. That means that you don't have to define what type of data before you can use any variable name. We'll see that a little bit down in the notes. But so all of these languages you see in here are loosely typed, like PHP, Python, and JavaScript, and so on. These are all loosely typed. And because they're loosely typed, they can be very tricky and very confusing to some programmers because a variable name can be assigned a certain data, certain value at any given time. Okay, so whereas in strongly typed, once you declare a variable to hold, let's just say name is a string type, then you cannot change that name to another type anymore until the end of the program. So you can't, right? So that is a good thing. And then the loosely typed, or sometimes we call those loosely typed as a lot of names, like a dynamically typed language. It's another one, okay? Or a weakly typed. So, and there are many more dimensions, but I just want to throw a few of these out there so you know what they are, okay? Okay, so Java is a strongly typed language. It's case sensitive. It's high level. Okay, and it's multi-purpose. So here is an example of a third generation I just mentioned about. You can see here we just drag and drop. There's no coding involved. Little code coding. You can go on at type level, right, whatever it is, but mainly just drag and drop. So that's the third generation of language you see out there. And so now you see that you might have seen advertisements somewhere else saying, hey, you learn how to code, learn to build your own app without knowing how to code at all. It's like these type of apps or languages. There's another dimension, right? We have the procedural and the object-oriented. Okay, so Java is an object-oriented language, and then we'll talk about that later and more. We'll go down to this example of the strongly typed and weakly typed, or loosely typed, right? Or dynamically typed. Again, a lot of names that mean the same thing. It just means that here, if I declare a variable called number, and of the type integer, and from there on, number can only contain integer. Okay, because variable means, that's what it means. It varies. You can reassign the number later on to a different number instead of 12. As long as it's an integer, then that's valid.
If I remember correctly, you know, the you can on a regular basis parse straight and the result of the
Yeah, there are ways that you can what we call cast, okay, or convert from a string to integer if that string contains a string of numbers, right? So if the number 12 is a string, so basically strings you put that in quotation marks. So if it's in double quotes, then that's a string. But because the actual value characters are numbers, then you can convert those into numbers. You can do that in Java and as well as many others, and vice versa. Okay. Okay, so just a few examples here, and then we'll do some more later in the code you see. So I just want to show you the different types of strongly typed and loosely typed. So these are strong types. So you specify the data type, and this is in Java. Okay, so Java, you put the type in front of the actual variable name, or we call those the identifiers, and then you assign it with the equal sign equal to something. Okay. And then the weakly type is like this. Like, for example, this is from Java, JavaScript, or PHP. They use kind of similar syntax here. As you can see, I just say $name is equal to my name. And then because the data type, I don't have to say it's an integer or it's a string type. It will be determined based on the actual value here. So it will be assigned dynamically based on the value it's stored. So later on down there, if I change to hold a different value, 1, 2, 3, now the data type has been changed from a string to an integer, and then from there to a Boolean, and so on. Okay, so it's very useful in that sense, but also can be confusing because if you don't check the type, and suddenly after this line true here, you try to do some type of calculation, you get an incorrect result. Okay, so I just give you some extra steps to verify the data type. Whereas up here, you pretty much know that, okay, the name is always a string, so therefore I'm good with that, right? Okay, so that's that one there. So a little bit about the syntax of Java. And then, again, just kind of repeating what I just mentioned, that Java is a case-sensitive language. So all these words here, the area, have different meanings, and they're all different identifiers. It's a strongly typed. A Java program executes or starts from the main program, the main method. Okay, so your program, what I say about your program means your application. So if you build an app or any application, usually like an app or, I guess, calculate your tax or a game, it doesn't matter. Okay, there's always have to have one main method somewhere in one of those classes. If you don't have them, then Java does not know where to start. Okay? That's the entry point to your main program. Okay, you can have many main methods. You know, you're not limited to one, but it will run the first one it finds. And so you just want to make sure that you have only one, and that is the main one that goes into your program. Okay. So all the source code in Java, so source code are the raw text code that you see, you write, are always in the form of a .java file. Okay. And then once you compile it, once you run it, we did a little bit last week with the JVAC, right? JVAC file compiler. So the compiler would run the source code, and the compiler converts it into another type of code called the bytecode. And then these are in the form of a .class file. You see that generated automatically for you by the compiler. And then now that file is not readable by humans, so we can't read it. It's all in the binary. And then from there on, then you have the interpreter. So we have a compiler to compile your source code to a bytecode that can be read by the machine. And then from there on, you have another special file called the interpreter. That's the Java. Remember we did like Java, the hello world. Okay, so that Java is a interpreter. It interprets that bytecode into machine code. Right, so you have like three layers right there. And then the machine code is, so the bytecode is actually sits on the virtual machine or the JVM, and that JVM talks to the underlying system. So it's that JVM that makes Java so special. It's so portable on any machine, any device you can think of. Okay, so without that, Java would be just like any other language. So like C, you know, Visual Basic, C++, and so forth, right? So these are some special characters, kind of hard to see, but just opening braces and close braces, and what they mean. Okay, so the opening braces here, if you are not familiar, that is a block of code. You usually put your code inside a pair of braces, and then you have a pair of parentheses here. Usually these are used inside some kind of expression or inside a function head, right? So those. The opening square brackets are used for arrays to denote the index of the array, and then this is for the double slashes is for a comment on a single line comment. And you have the /* for a multi-line comment, right? And the string uses the double quotes, and then you have the semicolon. You use that to end every Java statement. You must end every statement with a semicolon, otherwise Java will think that it's not a complete statement, so it will run until it finds the semicolon. And then if it doesn't find it, if you violate its rules, its syntax, you have an error. Okay? So just remember that it's always terminated with a semicolon. So I'm going to skip this. I'm going to go right into down here. Again, just kind of repeating what I just mentioned above. You can see where those stages are. So we have the initial part right here is to modify the source code, or you create your source code. This is the .java file at the very top here. Okay, so you will see your code like this. When you run your code, that's what you see. The source code compiles it by the Java C. You see that here, JAVAC. You compile it, and then it turns into a bytecode. And then the bytecode will be run by the Java interpreter, and then interpreter will run on the machine, and then you see the result, which is just welcome Java. Okay, so it goes through those processes. So you must compile in order to run, whereas PHP and JavaScript, those are interpreted language, so you don't have to compile, you just run right live on the website, right? So those are some differences. Okay, maybe another diagram will show you here again, kind of same thing here. So there are different layers here. So you see again your computer or any device, your microwave, right, or your car, doesn't matter. And then the JVM sits on top of that machine. Okay, so it talks to the machine here, and it talks to your source code. So that JVM makes Java so portable. Other languages don't have that, so that's why Java is the right one to run anywhere. Okay. So this is the compiler. Okay, the compiler Java C. Interpreter is the Java. We did that last week. If you don't remember, you can go back and look at this code here, and then compile your code on the command line. Add some instructions in here. I'm going to go down to this part here, identifiers. So identifiers are just what we call a placeholder, or something like, it's like, you think of it as a bucket to store some data, right? So a bucket of something can only hold one type of data. Like for example, if I have a cup to hold, coins, that only can hold coins. You cannot put, bills in there, right? Same thing. And identifier is a sequence of characters consists of letters, digits, and underscore, and dollar signs, and there are just some rules for Java. Every language has their own rules how you can use identifiers. Identifiers is the actual name of a variable. Okay, so it cannot be a reserved word. Cannot be, like, for example, these are reserved words: true, false, and null. These are already reserved words. Can be of any length. Usually, you don't want to make it too long, because when you type it, it's going to take too much to type. So not too long and not too short. Okay? Got to be just right. And we'll look at some examples here in a bit here. It's just that this rule is important. The second rule here must start with a letter, or underscore, or dollar sign. So just those three. You cannot start with a number. You can start with any other characters besides those three. Okay, a letter, uppercase or lowercase, doesn't matter, or the underscore followed by any of the characters, or you can start with a dollar sign and then followed by anything else. Okay. Constants. A named constant is a special identifier that holds permanent value. Okay, so you have the name constants here is a variable name, just identifier. It follows the same rules as how you name your identifier, except by convention we usually use all uppercase letters to hold a value, to hold a name. So when you see it, you know that, oh, that's a constant variable. It cannot be changed. The data cannot be changed when you execute your program, right? You cannot change it to something else. It's fixed. So to define a constant variable in Java, you use the word final in front of it. Okay, so final followed by the data type, and then followed by your identifier, and then you have to assign a value to it right away. You cannot leave that blank because it has to have some type of data. Okay, and then you have some other constants as well. Those would be like string literals or numeric literals. Like the actual number itself will be also a constant. Like, for example, 3.14. This is not a variable name. It's just a constant number, right? But that number can be assigned to another variable name, and then you can use that other places. But that's the name constant. Naming convention. So again, these are just conventions. Okay, there's no rule. You don't have to follow the rules here. But of course, as you become a programmer, you usually follow the same convention, so that other programmers will also follow this rule as well. But of course, rules are always meant to be broken, I guess, right? So just make things more consistent throughout your program, your code, or through other languages are kind of same. Is that you always use lowercase for variable names and methods. Okay, methods are function names. It's a special term they use in object-oriented languages. They always use the term methods instead of functions and sub-procedures and so on. Again, it's based on what kind of language you're writing. Like in Visual Basic, for example, we wouldn't say methods. We would say either function or subroutine, right? Because they are both separate. They have special keywords. We would say sub and function. Whereas in Java and other languages, you don't have to specify it's a function or not. You just say, you just write the name, and we know that it's a method. Okay, and then you capitalize the first letter of each word in the class name. And we'll talk about class later. So, so that's again just the convention. So it will look something like, for example, computer area or system or my favorite restaurants. Right? You will capitalize the first letter of each word. If it's a variable name, then usually you capitalize, you lowercase the first letter, and then you can capitalize each word after that if it contains more than one word in the name. Okay. And again, I just mentioned that all the constants are all uppercase, like pi or max value. So when you see it, you know exactly what that identifier stores. Okay. IO input here. We did a little bit last week already about the system out. Okay, output is always the system.out.print. Okay, The print comes in many forms. You have the print ln for print line, you have the print f for formatting. So those three are the three major ones. So for outputting, you put the system.out. Again, it's case sensitive, so when you write it, you have to make sure it's the capital S for the system. Okay, so again, why is that? When you see that, well, based on this convention, we say that, you know, classes have all uppercase, right? So we know that the word system is a class. So by looking at it, you know, oh, that's a class. Okay, and the follow-up out will be a attribute or a function or another field inside the system. So it's a sub of system, and the print is a function of the out. So each dot here, we call it those like a dot notation. You see that a lot in Java and many other object-oriented languages out there. Okay, you will separate each layer or each class by the dot or each field. Okay? You'll get used to these as you write your code. For output, it's really simple. That's all you have to do. You don't do anything else. Just say system out.print, and then you put that whatever you need to print out inside the print here. For input, you have to go like 2 extra steps. Okay, one is you have to call a scanner again. Capital S here. It's a class name, right? So it's a type. So if you look at this, a data type of type scanner. And then the variable name is input, and then you say new scanner, and then the system in here. Again, we'll do this later on, but just to show you that that's what inputting. You're reading data from the keyboard or from other files, okay, or from the file. And there are many ways to read data input. This is coming from directly from the keyboard, and you'll be using this a lot in this class. And then when you create that object, then now you can use that to read from the input, the keyboard, a double, an integer, or a character or a string. Okay, and we'll look at these later on. But you have several types here, so you can read the byte, read the short, int, long, and so forth. Code indentation. This is again for easy to see for readability purposes. You always indent your code, and there are many styles, and you can choose whatever style you want. And some of these styles have names based on the authors or the programmers, whoever found or created these, and become so popular so that they have names for them as well. And I can say that the most popular ones are the first two here, okay, the K&R and the almond styles. So when you write your code, you can use either one, however you choose it. By that I mean like the indentation of your code. So for example, the K&R style is you start your curly brace here and you end it here, and then at the same line as your statement, right? So in the case like this, is a while statement, or if you have an if block, or if you have a function or method, you put that in that same line, and then you end it over here, and you indent it, and then your code so it's nicely indented. The other one here, you put your curly brace on the next line, and then the match here to here. So these two are the most common ones. Okay, and so whichever you want to use it, it's fine. And the reason why you use this way is because you can see it, you can match it. So if I have another block in here, I indent that, right? You indent it in here, and then you see that they have to match. Once you match, then you don't run into issues like syntax errors and some unexpected logic errors and so forth. So use either one, however you feel is comfortable to you. And usually you want to establish your own way of style, your own style, and then then keep that, right? Don't switch back and forth. It's confusing, not to others but to yourself even. So many styles here, as you can see. And then, so getting close. This is the development process. I also have a video in there in the Blackboard as well. If you watch it, you'll see I do a little demo here. We're just going to show you that this is the same process that will go for any language, any program you're going to write. It doesn't matter if it's Java or not. Okay, it's always follow this process. You have the logic, of course. In order to write something, to build something, you have to have a logic or a problem to solve, right? What is that problem? So you write it out. You write it using pseudocode. Okay, if you never used pseudocode before, we'll do something here. Very simple. Pseudocode just basically instructions in English or in simple phrases that you use to make things easy to code. And then once you write your code, and then you would compile it, right? Run it, see if there's any syntax errors. The syntax errors would be like because you have to write your code to conform to the certain rules. If they all pass, then it will follow this execution of the program, and then you see the output of the result. Are the results correct? If it's not, then you have what's called a logic error, and then you go back and fix the code again until everything's okay, then you exit out. Okay, so this is a typical process. So we call this the input, process, and then output. A typical process for all languages. So here is a object. Okay, getting close to object-oriented. I'm going to zoom this in a little bit. So an object, if you think of an object just like a real object in the real world. Okay, so Java is a pure full-fledged object-oriented language. That means everything you write is based on objects. So if you think of object, you think about this, 3 dogs here. You have 3 types of dogs, but they're all dog, right? They belong to the dog class. So you would create a class called dog, and then once a class is created, you can create objects out of this dog class. So a class is really it's a blueprint. Okay, it's a blueprint to build some object. Think about a blueprint to build a house, right? Build a house or build a car. It doesn't matter. You always follow the same blueprint, and that blueprint doesn't do anything unless you make some object out of it, right? So a class is the same thing. It just has some code in there for you, and then in order to make that into something useful, you need to what's called instantiate. Okay, the term instantiate is used a lot in object-oriented language, or to create an instance of that class. And you can once you create that instance, then or that copy, and then all these objects here, although they are different, but they have similar features, exactly same features. They all have tails and ears and eyes, and they walk, they can bark, they can run, right? Although each of those are different types of dogs. Okay, so the properties and the functions are exactly the same. They're all shared equally across all these different objects. Just like you build a house from the same blueprint, you see that in some places you have all these houses like exactly the same. Some might have different color, you have different color, different texture, different material, but it's still the same design. So same, because that's exactly the same. So a class is used to create objects. So you cannot suddenly create an object and then from out of nowhere. Okay, you have to have a class first before you can create any object. Okay, so I call this the pi in OP here, but I will talk about this again in chapter 10 in more details. Well, these are the 3 pillars, or the 3 functions or features that a true object-oriented programming must have. Okay? If it does not exhibit any one of these, it's not a true object-oriented language. So one is the polymorphism. Polymorphism is like, and the principle of biology is that an organism or a species can have many forms. Okay, so like I mentioned, again, we'll deal with this later in chapter 10, but it has to do with what we call a method override. Okay, what that means is that, like, if you go up here and if I, like, this is a dog and a dog class, I can add another class above this so that applies to other animals. Like you can have a pet class, right? A pet class, and then a dog is a part of a pet, and then you can also have cat. It's also part of a pet. So cat is not a dog, but they're under that class called pet. And then so a dog can make noise. You can say talk, I guess. And it talks by howling or whatever, bark. And then a cat can also talk, it meows, right? So you have different forms, it does different things. It's kind of hard to see, but when we get there, you understand what polymorphism means. Okay. Inheritance, I just showed you that a class can share attributes and methods exist that can be shared across different subclass or classes if they have the same features. The inheritance, again, think about pet or animals, right? Animals is like the main class, the parent class. Under the animals class, you have subclasses that share some common features, like dogs and cats and mice can all share the animal class, right? Or if you think about vehicle, it could be a big class. Under vehicle, you have planes, you have cars, you have motorcycles, you have bike, right? And you can think about that. Oh, actually, then you can classify that even deeper. Yeah, like cars that are electrical, cars that are fueled by gas, and then you have into the motorcycles world, you have other subclasses, right? Yeah, and so maybe like two-wheel vehicles, like motorcycles and bicycles, or engine vehicles, right? You can have all those subclasses, and they'll all be inheriting from the big, giant class called vehicle. Okay, so it's like a child and parent relationships, or grandparents, if you want to even go that deep. Okay, so and then you will see the word extends in there. If you see the word extends in the class, like here, then that is an inheritance. So for example, a class called dog extends the pet class. That means the pet class is the parent class, and the dog is a subclass of that. So you have that inheritance relationship. Yeah. Yes, they're different. They're different objects, but they share the same methods or attributes. So I could have a cat as well extends the pet class, and they share something in common. Maybe like fur, right? They have fur or something. And then within their own class, they have some unique features that they cannot be shared by other classes, like dogs and cats meows. I don't know, maybe cat boxer, I don't know, I haven't seen one yet, but I guess they can be taught. And then the other one is the encapsulation here. This one here, we'll use it right away. You'll see that this is very common. Encapsulate means just, again, if you think about a capsule, inside a capsule you have layers of other smaller capsules, and the idea is basically to conceal your values. You conceal, so in other words, you're creating what's look like a black box. Okay? So for example, we're all like black boxes, right? We are all humans, we're all people. But we have our own concealed information. I mean, I don't know what you think in your mind, right? That's only data that you can know. So I cannot know. I can guess, but I will never know, and so on. So each of us is unique. We have similar features. We have, appendages and things like that are common. So we are a class of people, or human, right? And under that, you have the actual individual objects. Those are unique, okay? Just like you are. We're all unique, okay? And then we'll secure those or encapsulate those by using the word private. Okay, so I have an integer called age, and I want to set that to private. And then you make it private in front of it, so that only you or only the object can have access to that age variable. Other classes, other objects cannot access the data, and then they cannot know it unless you have ways to make it public, which we'll learn how to do that.
Is this one of the methods that software companies use to hide the source code of their data?
I'm sorry, the what?
Is this one of the methods that like software companies use to hide the source code of their data?
Yeah. Yes. Right. So, for example, they may give you, okay, these are the commands that you can use, right? And in order to use this command or whatever it is, you need to pass this data, this field, and then it will give you this output, right? You don't know what's going on inside, right? So the algorithm inside is completely concealed, or sometimes it's all like encrypted. You can't tell, okay? But all you know is like you need to put this in, you got this out, okay? So that's like the black box, yes. And that's a really good reason why you would do that, and as we get later, you see why and the usefulness of that. Okay, so this is the three major pillars of the object-oriented language, and there are more, but these are the main three features. So let's look at this. I think I'm going to skip this. We saw this already, right? We did that. already. And we'll look at the a typical shell code. This is also from the book of a Java class. Okay, and this class here, as you can see, is called any class name. This is just a shell code. It will look very similar to this one here. So every time you write a class in Java, it will look like this with a public class. So usually your class should be made public, otherwise you can't use it, you can't access it. But sometimes you have to you can make it private, but there'll be a class that is only called within another class. Okay, so most of your classes will be public. So the syntax is basically you have to put the word public, followed by the keyword class, followed by the name of the class. Again, the naming convention is you capitalize the first letter of every word in the class if it has more than one word, right? And then you have this main method here. This is the starting point of your program. So Java, when it runs it, the compiler will look for this void method. If it doesn't find one, it will try to look for a different class and find it. If you can't find it, it will just say, "Hey, I don't know where to begin." Okay, so you have to supply one. And then you can have a lot of methods, after the main method here. So let's look at this simple class here. It's called the first class, right? Class first. And then you have the main method here, and this is always like this. Public static void main. Public here again, you make that has to do with the encapsulation. So since it's public, that means it's visible to other classes as well. Okay. If you make it private, then of course this method here cannot be run by other class. So the public is the accessor or the modifier, and then you have a static. This is a special keyword to make this main method here executable by without having to instantiate an object. So usually when you create a function or another variable inside a class like this, you would have to create an object out of the first class here before you can use those methods. Okay? Again, I'll show what this means later on. But if you don't want to do that, you want to just run the command or the function directly without creating an object, and you make that static. Okay? And static also makes it available anywhere in your program, and then other objects can also access it as well. And then, so if you think of static, if you make a piece of data static, that means I can access it, you can access it, we can all see it at the same time. Like this projector here, screen here is static, as we all can see it. If I make changes to it, you can all see it, right? But if you make something changes in your screen, I can't see it, right? So that's only private to you. So static is just like that. So if you think about like I guess in a game or like a lottery, right? There's always one number that everyone can get it. Or in a game would be like when you have multiple players and they're attacking that monster or that last monster, and everybody can kill the monster. The lifeline can all seen by all other players. That's static. But we'll deal with that later. So the class name, they have a main method here, and then inside the main method you have some other algorithms or other statements to do something for your program. In this case, it's just printing the first statement to the console. Okay, so here, let's go a little bit further to explain what each of those are. Okay, so I just grabbed this from the book. I just thought I want to put this in this order. It's much easier to understand this way. I think the book has it in different order. But these are the key things about a class only in this first line here. So we have a class, public class is the name, and then put a curly brace to end that class. Okay? It's a class, and then you look at the main method here. Again, there's only one main method. So it will have a public static void, and then the arguments in here is just the one argument called args. Again, this args is the variable name. You can replace that with anything you want. Doesn't matter, X, Y, Z, A, B, C. It doesn't matter as long as it's in there. So the string is a type, and then the square brackets here just show that it's an array. Okay, so the argument here is an array of strings. and then again followed by the curly braces here, just show you that the block of code, what we call as the body of that function or that method. Okay, so the body of that class, body of that method. And then down here, just take a look at that statement itself, a Java statement. Again, you'll see this a lot. It looks very similar to this. Have a something dot something dot something, and it could be more dots in here. But in this case, you see 2 dots because we have 3 things going on here. So usually when you read the code in Java, in most languages also, it's always from the right to left. Okay, it's right to left, from the innermost to the outermost. So in this case, if you look at this, inside here, this is the actual arguments or the values being printed to the screen in this case. And then it's been printed by a function called println. And this function belongs to another class called in the out, okay, or another methods, another class here. And this out here belongs to another superclass called system. Okay, so ultimately the system is like the parent, and then you have the out under that, and then you have the function belonging to the out class. Okay, so, and then here these are some keywords in Java. There are only 50 keywords. Keywords are or reserved words that you cannot use in your code. I mean, I want to say use, you cannot use as identifiers in your code, right? So they're reserved. Okay. Although I think not always, I think 2 of these are not used. Like the word const. You see the word const, this is usually used in Visual Basic, but I think they just reserve it just in case they want to use it in the future. This one you probably don't use it. There's another one, I forgot which one, the import or something. Yeah. But most of these are used. And, you know, you probably, in this class, you probably won't use like the volatile, transient, and then synchronized. These are for like advanced features, but mostly just like the Boolean break, case, catch, and most of these different ones. So because they're keywords, so when you create variable names, these are not allowed, right? So if I say a Boolean type called final, I set it to true, because final is a keyword, so that will fail. Same thing here, the word this is also a keyword. As you can see, it's right here. Okay, it's not allowed. A function called try, okay, it won't work because that's reserved. Same thing, a class called goTo, right? You can't. But because Java is case sensitive, so if you just like capitalize it with a big F, it would have been okay. I put S here, but you could, if you capitalize it, then that's okay because it's case sensitive. It's not the same as the small F. But anyway, so finals is fine. That means that you can include keywords inside your word or words, and that's fine. And like this here, for example, both of these are keywords, but if you combine together, you can join them, then it becomes just a variable name. It's not a Java keyword anymore. And then the try here, again, I capitalize it, so it's now a valid identifier. Same thing with the goTo. Okay, so and if you want to know what each of these are, what they mean, we'll go into detail as we move along. But you can also get it from this Wikipedia link here. And then finally, I want to talk about these 3 types of computer errors. These are common errors, for any language you encounter. The syntax from the easiest type of error to detect and to fix to the most difficult. Okay? So the syntax errors these are just some incorrect usage of keywords, or you code your program incorrectly, you don't follow the rule of the language, then you have those errors. And usually the IDE will tell you right away when you run it. The error message will tell you. It's easy to fix. Runtime is the error runs when you executed the program. Like, for example, if you forgot to close all your resources and your computer runs out of memory, then it crashes, right? That's a runtime error, okay? Or it can also be caused by a syntax error that is not caught until you run the code. like it could be nested inside a if block, and that only occurs if that block is true. Otherwise, it will be skipped. So it could cause that. So these are also kind of easy to fix. The logic error is the most difficult. Okay, these are caused by incorrect output. Basically, you have an incorrect result, and you wonder why, because everything is you put the required data, you expect the result to be this number or this output, but it keeps printing something else completely different. And sometimes it's like no matter what data you put in, you always get the same result. So that's also a logic error. Yeah, right. So this is very difficult to debug, and then most programmers, when you write a really large application, you spend probably a huge chunk of your time just debugging. When you heard the term debugging, that's mostly logic error debugging. Okay. All right. Any questions on anything we talked about before we take a break? Okay, so we'll take a 10-minute break. We'll come back, and then we will dive into Java and the rest of the code.